Hello guys, how are you? Do you hear me? Hello? Hello? Who can hear me?
Hello, yes, sir.
Oh, Noor. Noor, would you please go to Zoom? Zoom, please. Go to Zoom. Right now I am open. I'm available via Zoom. So would you please join me using Zoom? Mustafa? Mustafa, you know that. I think you have joined me using Zoom. Amir Siddiq, would you please go to Zoom?
Okay, doctor.
Okay. Hello, Noor. How are you?
Hello, sir.
Okay, good, 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 good. Mateen, do you
Yes, sir.
hear? Okay, good. Glad to have you again.
Thank you, sir. Appreciate it.
Thank you. Yeah, who is that? Muhammad Suleiman. Okay, Muhammad,
Yes, sir.
would you please go to Zoom?
Okay, sir.
Yes.
Alright.
I'm available there, please.
Okay, sir.
Yes. Nafi, hello. Nafi, do you hear me?
Hello, sir.
How are you?
I am fine, sir. How about you?
Good, thank you so much. Now, right now, I have Nafi, Amir Siddiq, Mateen Ibrahim, Mustafa Saleh, and Noor Ibrahim. I'm still waiting for the others, so hopefully they will be able to join us using Zoom. Who is that? Khurshid. Khurshid, hello.
How is it?
Yeah, how are you? Khurshid, would you please join me using Zoom?
Okay.
Thank you so much. Okay. Muhammad, I got you. Muhammad Sulaiman, I got you.
Yes.
Okay, good. Adnan, do you hear me, Adnan? Adnan, do you hear me?
Yes.
Adnan, use this. Use Zoom and join me now.
Yeah. You sent
Yes.
the ID on the class.
Yes, of course. Yes, of course. Check your email and you're gonna find the details. Okay.
Good evening, Tutor.
Good evening. How are you? Shirwan,
Good, thank you. Yes.
good to have you in my class. Okay. 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 Right now I have 11. Hello, how are you, Muhammad? Hello again. Okay. Would you please, yeah, close your microphones, please? So, uh, okay. Okay. Okay, let me explain something to you. Using Zoom, we will have 40 minutes. Then we will have the first disconnection. You will have your break for 5 minutes. Then you're going to rejoin me again. So after 40 minutes, we will have the first disconnection. Then 5 minutes, I will rejoin the meeting again, and you will reconnect yourself to me again. Okay? So 40 minutes, we will have the first disconnection. Okay. Now I'm going to share with you the files that I couldn't share it with you last week, and I am going to start from the beginning. Okay? Let me see. Desktop. Okay. I'm sharing my file with you guys now. Who is iPhone? Who is that? Caesar. Hello, Caesar. Do you hear me? Caesar?
Yes, sir.
Caesar, would you please join me using Zoom? I am available now on Zoom.
Have you sent the
Yes, of course. Please check your email.
outlook?
Check your email.
You have sent from the Teams or outlook?
No. Email it. Email it to you.
Okay, I'll check it.
Okay, check it please and join me. Okay.
I'm sir.
Hello, Farad. Yes.
Yeah, I
Is my name front or iPhone? Because I opened from the phone.
I got both. Let me check that. Not this one. I have Furat iPhone.
Okay, sir.
Okay. Okay, guys, do you see the slides now? Is it clear in front of you? Guys, is it
Yes, sir.
clear? Okay.
Yes.
Okay. So let me get back, starting with how to calculate Z. I mean, I talked about you. I talked with you about how to calculate molecular weight, the apparent molecular weight. How can we calculate the specific gravity? And what does it mean, a standard volume? And what is the physical meaning of density? And of course, specific volume. These are really very, very clear. You just need to read them. This would not really very big deal for you, so I'm not gonna repeat myself here. But I'm gonna go with gas compressibility. This is really very important. Z factor. How to calculate Z factor? Now we have two options to calculate Z factor. We can calculate Z factor either by the graphical solution using what is called Z chart, or we can calculate Z using the analytical methods. Okay. Now, how can we calculate Z using the graphical solution, or using what is called Z chart? To use Z chart, you need to know what's called the pseudo-reduced pressure (PPR) and pseudo-reduced temperature (TPR). Now, to calculate PPR, TPR, you need to know what PPC, TPC, pseudo-critical pressure, pseudo-critical temperature, pseudo-critical pressure PPC, pseudo-critical temperature TPC. Okay, PPC, TPC, both of them can be calculated using the summation rule. What does it mean, the summation rule? It is similar to the way that we can use it for calculating what? The apparent molecular weight, the summation rule. Here is the summation rule. So PPC is calculated by multiplying the critical pressure of each component in the gas stream times the mole fraction. Now, the chemical composition and the mole fraction will be given to you from PVT study. From PVT study, they will let you know the chemical composition of the gas stream and the mole fraction. They're gonna let you how much C1, C2, C3, C4, C5, C6, C7, and so on. And of course, the mole fraction. Now, what do you need? You need to go to the textbook. From the textbook, you're going to find the critical pressure and the critical temperature. Each single component does have a constant value for critical pressure, that is PC, and a constant value of critical temperature, TC. Please close your microphone, please. Please close your microphone. Please. Let me see who is that. Please close your microphone. Okay. And I am gonna give you the permission to record, all of you. I am gonna give you the permission to record. You can record whatever we are going to cover this day. All of you does have the permission to record. Almost all of you can make the record if you would like. Okay, so the PPC, pseudo-critical pressure for the gas mixture, is calculated by the summation rule. So what you need to know the mole fraction, you need to know the PC of each component. The mole fraction will be given to you by the PVT study. The PC is taken from what? PC is taken from the textbook. and same thing for TPC. So you got PPC, you got TPC. Then you will be able to calculate what? PPR and TPR. So PPR is what? Your reservoir pressure, see? This is your reservoir pressure, see? Divided by PPC already calculated before. Let me change the color, okay? I think this is not help. This is not gonna help. Let me put it now. While TPR, see, is the reservoir temperature divided by TPC calculated before. Now, if you got PPR, TPR, then you can go where? You can go to the Z chart. See, this is Z chart here. So here is Z chart. What you have here? If you look carefully, you're going to find two parts. This is the upper part. See, this is the upper part. See, here is the line between the upper part and the lower part. See? So here is the upper part, and here's the lower part. Now, how much your PPR? If your PPR between 0 and 8, you can use the upper part. If it is more than 8 to 12, you can use the lower part. So this is your PPR. Where is your TPR? The curves here are your TPR. Let me assume that our PPR, see, this is PPR, our PPR is 4. See, so your PPR is 4. And let me assume that TPR is 1.5. Please follow me. So PPR4, this is PPR4, see, this is PPR4, see, this is PPR4. So we're going to use the upper part. Now move down, move vertically down to 1.5. Where is 1.5? This is 1.5, see? This is 1.5, see? So here is the curve for 1.5. So this is your intersection point. Now move horizontally and read the value of Z. Read the value of Z. So this is Z. How much? 0.78. Is that clear so far, guys? Is that clear? Is that clear how to calculate Z? Hello?
Yes, doctor.
Okay. Now, if PPR 12, you're going to use 12. This is 12. But you're going to use the lower part. And this time, you're going to move upward vertically. Okay? And look for 1.5. Look for 1.5. See? Here. This part. Okay? And then, from 1.5, unfortunately, the numbers, you have to follow the same sequence here. See? The same sequence. So this is a 3. Here is the 3. Then 2.8 to almost, this is 1.5. So 1.05, 1.1, 1.2, 3, 4, 5. Almost here. And you are going to read it from this part. See? So this is the graphical solution for Z. What you need to know pseudo-reduced pressure, pseudo-reduced temperature, PPR, TPR. To calculate PPR, TPR, you need to know what? Pseudo-critical pressure, pseudo-critical temperature, PPC, TPC. PPC, TPC, both of them are calculated using the summation rule. What you need to know how much the mole fraction for each component. This would be given to you from BVT study. And you need to know how much the critical pressure and the critical temperature for each component. And you can have them from the textbook. Each textbook of reservoir engineering, you can find at the end of the textbook, like tables, many tables. And you can find from one of these tables, you can find the critical properties of each component. Is that clear so far, guys? Is that clear? Is that clear? Okay.
Yes,
Now,
yes.
Okay. Now, if you do not have the chemical composition, let me say that you do not have the chemical composition. So you do not have the mole fraction. What can you do in this case? You need to know how much the specific gravity of the gas and the type of the gas. Do you have dry gas, natural gas, dry gas or wet, or you have condensate? If you have natural gas, and if you know the specific gravity of the gas, then you can use these two models. See, these two models, see here, to calculate what? To calculate PPC and TPC. This is for natural gas, wet and dry. So what you need to know the specific gravity of the gas. Then you will be able to calculate PPC, TPC. So PPC, TPC in this case they are not calculated by the summation rule, but they are calculated using these two models. Then known PPC, TPC, known reservoir temperature, temperature, reservoir pressure, you will be able to calculate PPR, TPR. Then you can go to the Z chart, get the value of Z. In case if you have condensate, retrograde condensate, or near critical, you're going to use these two models. See, these two models. So by graphical solution, either using the summation rules to calculate PPC, TPC, if you have the chemical composition, or if you can use the analytical models to calculate PPC, TPC, but you need to know the specific gravity and the type of the gas. If you have natural gas, wet or dry, or if you have gas condensate, either retrograde or near critical, then you can calculate PPC, TPC. So here is the graphical solution. Now, as I told you, we have either the graphical solution for calculating Z factor, or sometimes we may go with the analytical calculation of Z factor. There are three techniques for calculating. There are three techniques for calculating Z analytically. The first one is Hall-Yarproof. The second one, Dranchuka-Abu Qasim, and the third one, Dranchuka-Parviz-Robinson. So three techniques can be used to calculate Z factor analytically. The first one, Hall-Yarproof. The second one, Dranchuka-Abu Qasim. The third one, Dranchuka-Parviz-Robinson. Now, Dranchuka-Abu Qasim, Dranchuka-Parviz-Robinson, almost similar. So we are going to talk about Dranchuka-Abu Qasim, and I'm going to leave Dranchuka-Parviz-Robinson to you. Okay, let us start with Hall-Yarproof. Hall-Yarproof said that Z factor can be calculated using this model. Please give me your attention. Using this model. So this is the model to calculate Z. See, guys, 0.06125 pseudo-reduced pressure, PPR, times T. We will see what does it mean, T, divided by Y, capital Y, exponential minus 1.21 minus T, all square. So Z is calculated by this model. Now, what is T? This is T. T is the reciprocal of pseudo-reduced temperature. So the reciprocal of TPR. What does it mean, the reciprocal of TPR? It is TPC divided by T, because we know that TPR is what? TPR is reservoir temperature divided by pseudo-critical temperature. So it is T divided by TPC. Now the reciprocal is TPC divided by T. This is T. You're going to put it here. You're going to put it here. Now what is Y? Now Y, I mean, the whole procedure, the whole story of Hall-Yarproof, the whole story is focused on how to calculate Y. Y is the reduced density, and it can be calculated by the iteration method. See what I'm saying? Y is calculated by the iteration method. What is the condition for Y? What is the condition for Y? Now we need to calculate a function of Y called Fy. And Fy must be actually, Fy, see this is Fy, must be equal to what? 0. Now, what we have in Fy? We have x1. What is x1? Here is x1. X1 is a function of what? PPR, we know that. T, we know that. T, we know that. Y, we need to know how much Y. Y2, we don't know how much Y. Y3, we don't know how much Y. Y4, Y. X2, here is X2. See? Y square. X3, here is, yes, here is X3. And X4, here is X4. So basically, we can calculate X1, X2, X3, X4. We do not have a problem with X1, X2, X3, X4. Now, what is missing here? The missing value is Y. We need to know how much Y. So when we put Y in this model, we can reach Fy to be equal to 0. See what I'm saying? Now we are gonna start our iteration method. It's kind of trial and error. See what I'm saying? Trial and error. So the steps, the protocol for finding the value of Y is, so we are going to start with what? We are going to start with some value of Y. So the first value of Y, guys, the first value of Y, here is the first value. Y is 1. YK, K is the counter. So the first value of Y, 0.0125 PPR. We know how much PPR. T, we know how much T. Exponential, minus 1.2 times 1 minus T all square. So we know all of that. So we're going to put all of them in this model, and then we are going to calculate the first value of Y. So we got Y. Now, when we got Y, we will get back to what? We will get back to the model for Fy. Now we know how much Y. So we will get back to this one here. No, we know X1, we know Y, we know Y, we know Y, X2 known, Y known, and then we will see, is it 0? If it is 0, so here is Y. If it is not 0, then we need to try another value for Y. Okay, so the new value of Y, is determined. See, the new value of Y is determined. This is the new value. See, the first value of Y minus the function of Y, the value of the function of Y, how much you got, divided by the F dash Y, the first value, the value of Fy dash when Y1 is used, and F dash Y is calculated by this model. See, we know Y, we know Y, we know Y, we know all of that. Then we will be able to calculate F dash Y. We're going to put it here. Fy already calculated. Okay, and we know the first value of Y. We will be able to calculate Y1, or let me say Y2 in this case. Y2. Y2, we're going to put it again where? In the function of Fy. Is it 0? If it is 0, so you're going to say, okay, here's our Y. If it is not 0, then we will get back here. And we are going to repeat ourselves until the difference between Y and the other Y, the next Y, less than 10 to the power minus 12. See, less than 10 to the power minus 12. Is that clear? Is that clear?
Yes, Doctor.
Yes, sir.
Okay. Who could write a code? Who could write a code for this problem using MATLAB? Who could write a code for this problem using a MATLAB code? Do you know how to use MATLAB?
No, sir.
Who knows how to use MATLAB?
Sir, we don't know.
You don't know. Who knows how to use Python?
Sir, we don't know we are not familiar with the softwares at all of the students.
Who's talking to me? Let me get back to you guys. The problem, I do not have okay, it's very typical here that the power is shut in. So, okay. Who is that? USZF. I don't know what's your name. YSZF VF5. Who is that? Who's talking to me?
It's me.
What?
You mean
Yes.
my name, sir?
Yes,
Mine is Muhammad, sir.
Muhammad what?
Muhammad Ahmad, sir.
Muhammad Ahmed, because it is written here like YSZV.
Sure, it's first time using Zoom, so I don't know what's the
Please,
problem.
next time, change it to your name. Give it your name so I could know who's talking to me.
Okay,
Muhammad, and all of you guys. Muhammad and all of you. Listen to me, guys. Nobody. Okay, we are 10 minutes away from the first disconnection. Guys, listen to me. Nobody gonna teach you how to use the software. It's not part of our job to let you know how to use MATLAB. It is not part of the academic teaching process to let you know how to use Python. It is part of, it's your responsibility to develop your skills in something like that. So please do not say, I don't know. If you would like to develop your skills, yes, you can do it. MATLAB, you can get it everywhere. I mean, I don't know if you can get it in your campus. Is it possible to get MATLAB?
No,
Sir,
sir.
it's
No.
not in study plan.
What's that?
I mean, we didn't know about the software, and it's not in our plan, study plan.
However, you listen. I'm not gonna encourage you to get it illegal, but if you go to the I don't know, to the computer stores, you can ask them, I need the 2 CDs of MATLAB. They can give it to you. I think probably 3,000 or something like that. It's very cheap here. And then you can go to, for example, you can go to the YouTube and say, how can I use MATLAB? You will have a lot of video tapes that could teach you how to use MATLAB. And you, by the way, Python, you can install Python free of charge. No, you can install it. You can install Python free of charge. And again, you can go to the YouTube and like ask for Python tutorial. And you will have a lot of video tapes. Then you can develop your skills. What I need to emphasize: nobody here, nobody in the campus, not only your campus, everywhere. Nobody gonna teach you how to use the software. It is part of your responsibility. I wish, I hope, if you could, let me say, if it is not Python, MATLAB. So, for example, this is a problem. You can write a code, and believe me, when you start writing a code or something like that, you will be very happy, and you're going to develop your skills, and it will be very appreciated when you will be graduated. When you put in your resume that you know how to use MATLAB, you know how to use Python, you know how to use CMG, it will be very appreciated. Believe me, everywhere, not only here. See what I'm saying? So next Wednesday, hopefully next Wednesday. The problem, I don't know. I will try to write a code using MATLAB, and I will try to show it to you. Okay, how to use the code, and hopefully I will be able to show you all the details for the code and the value of Z. Okay, let us get back now. Okay.
Sir?
Yes.
Sir, do you have examples for these things?
Yes, of course. If you go to chapter 2, Tariq Ahmed, it is taken from chapter 2, Tariq Ahmed. You're going to find a lot of examples.
Sir, can you upload the book on Team, please?
Can I upload?
The book?
Oh, yes, it is already. Oh, okay. Yes, I can upload this one to you. So it will, but you can get it free. I think you can get it free. You can get it free. However, if you need the textbook, I can do it now. I can upload the textbook to you now, or okay, you can go to the to our team, a Microsoft team. I'm going to post the textbook there. Okay?
Okay, sir, thank you.
Yes. Okay, let me get back to my slides. So this is Al-Rbeawi. Now, the second one, Dranchuka-Abu Qasim method. Now, Dranchuka-Abu Qasim method, this method says that we need to develop what is called reduced density, rho of R, reduced density. And Dranchuka-Abu Qasim, they define reduced density as the density at any reservoir condition, the density of reservoir fluid at any reservoir condition divided by the density of reservoir fluid at critical pressure, critical temperature. Now, we know that the density is what? The density, if you remember, guys, that the density is what? The density from the equation of state, rho is what? Rho is pressure times molecular weight apparent times what? Z RT. This is the density. See? Here is the density. See? Now, the density at any reservoir pressure and reservoir temperature divided by the density at critical pressure and critical temperature. So this is P, reservoir pressure, molecular weight apparent, Z RT at any reservoir temperature. PCT, rho C, so it should be calculated at a critical pressure. So this is critical pressure. Molecular weight of the gas will be the same. Z at critical, R same, gas constant, universal gas constant, T critical. So molecular weight gonna go with molecular weight, R gonna go with R. So what we will have? Reservoir pressure divided by ZT, critical pressure divided by critical Z, critical temperature. This is for the gas mixture, of course. And we know how to calculate PCTC. PCTC is calculated from the summation property if we know the gas composition. It has been found that the critical Z almost close to 0.27. 0.27. This is critical Z. So we're going to put, instead of critical Z, we're going to put 0.27. So what we will have, P divided by ZT. Okay, so let me clear this one. So what we will have, see, this is P, pressure, okay, and here is ZT, see, and ZC, this would be 0.275 up, see, move up, 0.275. This is what? 0.275. This is TC, see, and what we have down, PC. Now, P divided by PC, what is that? P divided PC, what is that? Pressure, reservoir pressure divided by critical pressure. What is that? This is PPR, reduced pressure, and TC divided by T here. What is that? This is the reciprocal of what? The reciprocal of reduced temperature. So this is what? TPR. So here's what we have. So therefore, the reduced density is 0.275 ppr divided by Z, this is Z, and TPR. See? Now, the condition in this case will be the function of the reduced density, F rho R. F rho R should be 0. It is similar to Fy given by Al-Rbeawi. So in this case, we're going to work with F rho R. So R1 rho R, R2 divided by rho R, R3 divided rho R square, R4 divided by rho R5, so and okay. Now what are these? Now R1, R2, R3, R4, R5, A11, these are constant, can be determined from these. See? Here, see? R1, R2, R3, R4, R5. While A's, A1, A2, A3, Look, guys, give me your attention, please. Give me your attention, all of you guys. See, we will have the disconnection soon. See, this is A4. This is A4. It is written AR. It is A4 actually. And this one AT. It is A5. See, guys? I put it here similar to what was written in the textbook, but there is some typo in the textbook. This would be A4. This would be A5. Please, is that clear? I put it in my slide similar to what was written in the textbook. But what was written in the textbook is mistakenly written like IR, I sub T.